My name is Ian Ingram, and I work at the San Diego Zoo Wildlife Alliance. I lead the Conservation Technology Lab there, and as we'll see, oh, there we go. So, as I was saying, I come from the San Diego Zoo Wildlife Alliance. We're an alliance too. I guess EarthRanger and SMART are now an alliance. And I'm going to talk to you a little bit about SageBRUSH, which is a system that we use in Southern California and a couple places that we work, specifically with burrowing owls in translocations, and also in our own biodiversity reserves, one of which is immediately adjacent to our lab, and one of which is a little further away. Would that usually be the button that does it? These are burrowing owls, species of owl that uses the burrows of other animals, mostly California ground squirrels where we live. Here we go. So I just wanted to introduce my team to start with. As I said, with the Conservation Technology Lab, we're a group of 5 engineers embedded in the Conservation Science program at the San Diego Zoo, and we're strongly amplified by volunteer engineers who work with us. And then very importantly, a big part of our mission is education of future conservation technologists. We have a program for undergrads and graduate students in the area who are studying computer science and various stripes of engineering to work with us. And over the last 5 years, we've had something like, well, actually exactly 39 such people come through our lab. So SageBRUSH, the brush stands for Biodiversity Reserve Ubiquitous Sensing and Habitat. And it's both about the fact that we use it in our own biodiversity reserve, but also it's applicable to other biodiversity reserves. And the SAGE connotes the fact that we have machine learning built into the system in various places, and also it all is a nod to the fact that we are using it in the coastal sage scrub community, plant community in our area. So it's a lightweight, easily distributed system of networking nodes and then sensors that feed back into that. And as you could tell from the other slide, we're using it with rattlesnakes and with mountain lions and with cactus, wren, and other species in the area. So part of the idea is that we needed to network these areas that didn't have any kind of system in place, so we developed it around this idea that these things could be hiked in by a couple of people and set up. So we have these SageBRUSH stations, which are in many cases a lot like that one in the far right corner, although there are many configurations that do different things. In this case, it's a LoRa gateway with antennas, and you put them where you need them to be. Some of them include bridge radios to push more data from equipment. Oops, you did. And then we use it with a whole range of different things. A lot of it is simple sensors like humidity, temperature sensors that we can distribute across the landscape. We use LoRa to connect back, so we can get the kind of dense information that's useful to some of the ecologists who are studying the species in those areas. But we also are building out these other technologies that are mostly edge AI, tiny ML devices that then feed back through the LoRa networks. In this case, it's an acoustic device that is designed to be fairly low power, run machine learning inference on the device, and then telemeter back the results. One of the primary use cases is the need to do these widespread assays for burrowing owls across much of Southern California, where we can't really have teams go back and retrieve audio loss or other acoustic recorders like we use the other one from the original folks, but anyways, audio mods. We can't send that many people into the field, so we are trying to create this sort of wide LoRa network across the area, and then put these tiny scrub mics into place to pick up the species. There's no recording that takes place on the device at all. The idea is really to work towards smaller and smaller devices that can be made many of, and we have a lot of partners who work with us who can aid us in that effort to make these tiny models that do what we need. Oftentimes they are just binary classifiers, burrowing owl, no burrowing owl, and then tuned to work with high precision so we can try not to get too many false positives. And then similarly, we have a tiny ML camera called Tiny Scope Cam, and again, it does the inference on the device. Uses LoRa to send small amounts of data back per the application, relatively low power. We have a number of different configurations for these things. As you see in this slide, this one actually has a PIR, like a regular camera trap. So it is still using that to detect what it wants to run inference on, and then runs the model, and then telemeters back whatever needs to be known about the thing. So these are some of the applications. One of the primary ones that we use is the autonomous response. We had deterrents in our biodiversity reserve for mountain lions that would play sound all the time, and it was A, noise pollution, not so great for a lot of the animals were there. B, the cougars can get acclimated to it. So we use tiny scrub cams that are located in places where the mountain lions are often trying to do things that only play the deterrent sounds when they see a mountain lion. And then there are some other applications that I think folks that are familiar with these kinds of devices probably are also thinking about. And then in a slightly less constrained context, we have the Sage cams, where we are doing continuous inference on the video stream. Either sending the video stream back to a server and then running the model there, or doing inference on the device and then sending back clips, but still with a pretty heavy connection back to the database. And these are kind of what they look like. We've used them in the Arctic too for monitoring polar bear maternal dens, and we use them for sort of time lapses of the landscape, and a system we call Pinpoint that marries an object detector to a motor control system on the PTZ cam that this has, so that it can track wildlife in real time when we need to be able to watch them as they move around a particular area. And then we also use it for sort of panning time lapses and a number of different things. In this case, you can see, a nanobeam bridge radio that's allowing us to telemeter all that data back if we want to. And then similarly, we have the Sage mic that does the same kind of thing. Continuous inference on the device, often using off-the-shelf models like BirdNet or Perch or what have you. A lot of times training our own models, or using BirdNet as a feature extractor and then having a classifier head to do what we need on the end. Sometimes just a support vector machine that takes that data and does what we need. Two basic versions of it. One, again, where it does inference on the device and then telemeters back clips that are detections. And then the other is streaming all the data back and then running a more powerful model on data back on the server. Yeah, and so those, unlike tiny scrub mics, are designed to work in places where you're not as resource constrained. You have more power to work with, so we put them on the SMART-EarthRanger stations and also on the Alert California things that are going in soon. And then behind all of this, we have SageBase, which is our database for putting all this stuff and then making it available to various downstream systems. And it's a Postgres database designed around gathering all the data we need to have and trying to meet with fair and care principles and inherit from Darwin Core and Camera Trap DP in ways that make it compatible with a lot of our collaborators' workflows. And this is the data model. This is the entity relationship diagram for the data model. Some of the things that make it Darwin Core-esque, some of the innovations in terms of what it needs to have, because it needs to have occurrences, which I think are also being worked back into Camtrap DP. And then we use EarthRanger on the end for a lot of people who need to use it, like the ecologists. We give them EarthRanger accounts so that they can get the data back from the system and use it for their purposes. And that is all I was going to show you today.